So let's look at another example here. According to the National Weather Service, the probability of a tornado in Kankakee County is as follows. So 0 to 5 tornadoes, and then these are the probabilities. So probability of 2 tornadoes, 20% of the time. 4 tornadoes, 10% of the time. So that's the data we're given for a random variable. These do all add up to 1. Probabilities total to 1. We want to find mean, variance, and standard deviation first. So the mean is the sum of the x p of x column. So we need to, and then the standard deviation involves the sum of the x squared p of x. So we need to fill in our extension table and find our totals here. So 0 times 0.1, 0. 1 times 0.4, 0.4. 2 times 0.2, 0.4. 3 times 0.1, 0.3, 4 times 0.1, 0.4, and 5 times 0.1, 0.5. So if we add these up, let's see, so 8, 7, 15, 22.0. So this is our mean, which is the sum of x times probability column. So that's part A. And then let's work on variance next. So 0 squared times 0.1, 0. 1 squared times 0.4, 0.4. 2 squared is 4 times 0.2 is 0.8. 3 squared is 9 times 0.1, 0.9. 4 squared 16 times 0.1, 1.6. And then 5 squared 25 times 0.1, 2.5. So now we want to go ahead and add those values up. So let's see, we've got 1.2 and 1.6, 28, 37, 4.7, 5.7, 6.2 it looks like. So that is the sum of x squared times p of x. So next we want to go ahead and find our sigma squared, which is the sum of the x squared times probability minus the mean squared. So that's going to be the 6.2 minus the mean is 2, so minus 2 squared. That's going to be 2.2. And then sigma is going to be the square root of 2.2. Compute that. So second square root, 2.2, 1.48 approximately. So there's part A. Part B, interpret mu. So that 2 on average, that's saying that we expect 2 tornadoes in a typical year in Kankakee County. So 2 tornadoes on average per year. Part C, find the probability of at least 4 tornadoes. So that's saying find the probability that X, number of tornadoes, is at least 4, so greater than equal 4. So greater than equal 4 would be 4 or 5. So this is saying probability that X equals 4 or 5. So that or means we're going to add the probabilities. So this will be 0.1 plus 0.1. These two guys here, 0.2. So 20% chance. D, find the probability that X is within 2 standard deviations. So mu minus 2 sigma is less than X is less than mu plus 2 sigma. Let's go ahead and substitute our values in here. So this is asking us, mean is 2, minus 2, and then our sigma was 1.48. So minus 2 times 1.48 is less than x is less than 2 plus 2 times 1.48. So let's go ahead and figure those numbers. So 2 minus 2 times 1.48, negative 0.96. And then on the high side, 2 plus 2 times 1.48, 4.96. So that's finding the probability that x is between these two values. Well, that's saying that x, if it's, well, all these values are greater than 0, and then we want the ones that are less than 4.96, which would be everything except 5. So this is saying probability that x equals 0, 1, up to 4. So 0 or 1 or 2 or 3 or 4. So we're going to add these probabilities. So 0.1 plus 0.4 plus 0.2 plus 0.1 and plus 0.1. So 0.9. So 90% chance that the number of tornadoes is within 2 standard deviations. And then E, graph our distribution. So we can do a bar graph here. So on the vertical is going to be our probability. On the horizontal is going to be our number of tornadoes. So on the horizontal we've got 0 through 5. So I'll do 0 here, 1, 2, 3, 4, and 5. And that's x, number of tornadoes. On the vertical, we're going to have the probability of x. And those values go from 0.1 to 0.4. So why don't we put 0.4 up here. Halfway there would be 0.2. And then halfway between those, 0.3 and 0.1. So 0 had a probability of 1. So we want a bar centered over 0 of height 0.1. Sorry, not probability 1, probability 0.1. 1 had probability of 4, so I have a bar centered over 1, goes up to 0.4. 2 had a probability of 0.2, so we got our bar centered over 2, goes up to height 0.2. And then 3, 4, and 5 all had probability of 0.1. So those will be the same height as 0. Got a rectangle there, and one here, and one here. So that's a graph of our probability distribution. And we see that this is not symmetric. In fact, we draw our approximating curve that goes through the top of those bars. It looks like it's skewed to the right. So not a symmetric distribution.